Hi my dear friends, welcome back to our YouTube channel ADC Max. I hope everyone is doing well in your end. Please kindly take care of your health, stay safe, stay healthy and stay happy. It's very important, okay? Because our mental health is very important, both physical and mental health. Please kindly maintain the balance. So what I'm saying that here, in this video, I go probably another short and sweet problem with the help of the complex Fourier transforms. As we already know, the complex Fourier transform of f of x is f of s. It's a mapping between the f of x and f of s. Once the Fourier transform exists, then the inverse is possible. So the Fourier transform of f of x is equal to 1 by square root of 2 pi integral minus infinity plus infinity f of x. What about the input here? Whatever the input we have, so substitute here, and this is called the kernel of the transformation. So the kernel is completely depends upon the parameter s, so the outcome is this. I is a complex variable, so that's why it's called complex Fourier transform. That's in inverse, so the input is yes, the outcome is x. That's it, right? So the input is yes. What is 1 by I? Minus I. So minus I. So we are going to integrate this with respect to yes. So the outcome is x, because this is also f of s. So once this is possible, I can use this value here. We get the output f of x. And finally, transverse identity. We can make the modulus square, and both the sides we get the answer. The input is f of x, so f of x whole square under the modulus, the same under the modulus whole square under the variable s. So that is called the transverse identity. Clear? Now see this question. Obtain the Fourier transform for the function f of x equal to 1 minus mod x in mod x less than or equal to 1 and 0 in mod x greater than 1. And hence deduce that 0 to infinity sin t by t whole power 4 dt. Yeah, let us see that. First find out the Fourier transform. So what's the Fourier transform of f of x? As we know the formula, the first formula. But in this case, the function is defined in the interval minus 1 to plus 1. In the interval minus 1 to plus 1, that is the answer is 1 minus mod x. Otherwise it is 0. Right? So it is integral minus 1 to plus 1 minus mod x into e to the power I s x into dx. I think modulus function is always an even function, first thing. And e power isx, can I read this e power isx by? So integral minus 1 to plus 1 minus mod x into e to the power I theta capital cos theta plus I sin theta. Is right, sir? Into dx. Already we are very familiar. Cos is an even function, sin is an odd function, and mod x is an even function, so this is also even. So even to even is even to odd is odd. So once even to even is even, then we can rewrite minus 1 to plus 1 by twice the time 0 to 1 minus x into cos sx dx. What about the modulus sign? Yeah, modulus sign becomes plus x because of what's the definition of mod x? The definition of mod x is plus x if x is positive and minus x if x is negative. Right? Now my interval is only the positive because of 0 to 1. 0 to 1, so it is the positive sign only. So here it is positive x. So that's why I remove the modulus sign. And what about the even to odd function? So if it is an odd function, the integral value is 0. And if the odd function, it is integral is 0. The property says that the integral minus a to plus a. Generally, f of x dx is equal to twice the time integral 0 to a f of x dx. If the function is even, it is equal to 0. If the function is odd. So by using this property in the definite integral, I got this step. So once we will get this one, we can integrate this with the help of Bernoulli formula. So 2 into uv, what's in Bernoulli formula? Integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. up to infinity. Dash represents the derivative, v1, v2, v3 are the integral values as you know. So 1 minus x u v1 cos sx integration sin sx by s minus formula minus 1 minus x differentiating with respect to x, we get this minus 1 sin sx integration minus cos sx. So minus cos sx by s square, because already we have one more s here. So one more time with respect to x we get one more s. So s and s square. What about the next term? The next term is 0 actually. So let's close this term. So x is equal to 0 to x is equal to 1. Clear? If I substitute x is equal to 1 in the first term, I substitute x is equal to 1 in the first term, what I get in that? 1 minus 1, 0. 0 nothing, 0. What about when x equal to 0? Sine 0 is 0. So this term is completely 0 for both upper and lower limit. Got it? Right? So I can omit that one. I simply omit the first term. Because of when x equal to 1, 1 minus 1 is 0, 0 nothing, 0. When x equal to 0, yeah, 1 minus 0 is 1, but here unfortunately sine 0. Sine 0 is 0, so this term is 0. So what's the balance? Balance is only this term, minus and minus plus, plus and minus minus, 1 by s square. So can I take the 2 into minus 1 by s square outside? So what's the balance term? Only cos s6. So cos s6, and I substitute x is equal to 1 and 0, 0 and 1, what will we get? 2 into minus 1 by s square. By putting x is equal to 1, we get this cos s. By putting x is equal to 0, we get cos 0 is 1. And I multiply minus sign into the term, we get this 2 by, that is 2 into 1 minus cos s by s square. I think so. In the formula, I forget to write 1 by square root of 2 pi. Is right? So 1 by square root of 2 pi. Is right? So 1 by square root of 2 pi. Is clear? Is right? So after cancelling 1 root 2, 1 root 2, this becomes root 2. So it is root 2 by pi. So it is root 2 by pi. So it is root 2 by pi. It is square root of 2 by pi. So square root of 2 by pi. So this is the Fourier transform of the given function f of x. Is right? So this is the Fourier transform of the given function f of x. So I found the Fourier transform of this function. The output is f of yes. Yeah, yes only is no problem. Yes, everything is correct. Yes, right? But the deduction part is in terms of sine t by t, sine t by t. But here we have only cos term. So first, my aim is to convert this cos term into the sine term. So how we are going to convert it? Let us see. How we are converting it? Let us see. I am going to use the trigonometric identity. What's the cos 2 theta in terms of sine? 1 minus 2 sine squared theta. Is right? Am I right? Can I rewrite this by 2 sine squared theta is equal to 1 minus cos 2 theta. Now I want to substitute theta is equal to s by 2. So if we substitute integral s by 2, what happened this term? 2 into sine squared s by 2 is equal to 1 minus cos 2 into s by 2. So what happened? 2 to get cancelled, this comes 1 minus cos s. So what is 1 minus cos s? Is equal to 2 sine squared s by 2. So the equivalent of f of s is nothing but square root of 2 by pi. Now 2 into sine squared s by 2 by s. Otherwise 2 into square root of 2 by pi sine squared s by 2 by s squared. S squared. S squared. So this is my f of s. So convert this. Why I want to convert this? Because of my requirement is sine only. So that's why I can convert it. Right? Now even though after converting I have seen that it is the power 2 only. Power 2 only. But the deduction part I need power 4. Suppose power 2 is the requirement, then you apply the inversion formula. You apply the inversion formula with the power 2. But unfortunately we need power 4. So what we can do? We can make the square. We want to make the square means use the Parseval's identity. Clear? Use the Parseval's identity to get the deduction part. So that's a concept. Clear? So now what is the Parseval's identity? Before going to that, what I needed? I want to deduce. So to deduce integral 0 to infinity sine t by t whole power 4 dt. Suppose this is power 2 means what we will do? We apply the inversion formula, we will get the answer. But power 4. Power 4, so we use squaring it. So we want to square means apply the Parseval's identity. So I am going to use the Parseval's identity. So by Parseval's identity for the complex Fourier transform integral minus infinity to plus infinity modulus of f of s to the whole square ds is equal to integral minus into plus infinity modulus of f of x to the whole square dx. So let us substitute the f of x and the corresponding Fourier transform values. What I needed here, sine. So use this sine term. So on the left hand side, this becomes integral minus into plus infinity modulus of 2 times square root of 2 by pi sine of sine square s by 2 by s square. So this is the f of x into ds. In the right hand side, f of x. What's f of x? F of x is defined interval mod x less than or equal to 1. That means minus 1 to plus 1. So minus 1 to plus 1, 1 minus mod x to the whole square. Again the modulus to the whole square dx. As already you know, the modulus functions are always even functions. So this can be twice the time integral 0 to 1, 1 minus x to the whole square dx. So once we integrate this one, what we get? 1 minus x whole power 3 by 3 into minus 1. With the limit 0 to 1, we substitute x equal to 1, we get 1 minus 1, 0. T x equal to 0, we get it is 1 by 3. So it is 2 into, right? The upper limit is 0, the lower limit is, upper limit value is 0, the lower limit value is minus 1. So what is that? I think so minus 3 taken outside, 0 minus 1. So the answer is 2 by 3. So the left hand side, it's in terms of yes, the right hand side it is only 2 by 3. Clear? By putting x equal to 1, 0, x equal to 0 is 1, 1 by 3. Upper limit minus lower limit, it is 1 by 3. There is 2 into 1 by 3 is 2 by 3. What about the left hand side? When you make the squaring of the left hand side, 2 squared 4, root 2 by pi, 4 squared is 2 by pi, so this comes 8 by pi. Integral minus infinity to plus infinity, sine square s by 2 by s square, the modulus 4 square dx. Once again, this is an even function. This is an even function under the modulus function. So it is an even function. We can rewrite this by 8 by pi into 2 times integral 0 to infinity sine s by 2 by s to the power 4 ds. You see that power 4. How this comes power 4? Plus power 2 is common, whole power 2. So 2 into 2 becomes 4. Right? By law of indices, a power m n equal to a power m into n. So sine s by 2 by s whole power 4 ds. So I think here 2 into 8 by pi, here 2 by 3 is the right answer. Just do some simplification, that's it. We almost reached the answer. We do some simplifications. Because the question is only sine t by t whole power 4, but here we are having s by 2. Clear? In the right hand side is 2 by 3. So what we are having here, s by 2. So can I use some proper substitution here? S by 2 is equal to t, because the requirement is t only. So by this way, s is equal to 2t. So what about ds by dt is equal to 2. Otherwise, ds is equal to 2 into dt. So when the limit for s is equal to 0, t is also 0. When s is equal to infinity, t is also infinity. So let us rewrite this last step in terms of t. Last step in terms of t. So what happened? The last step is the last step. I think so 16 by pi. First of all, on the left hand side, the limit 0 to t equal to 0 to infinity is right. Sine of s by 2 t. What about s? S is equal to 2t whole power 4. What about ds? ds is 2 into dt is equal to, in the right hand side, is 2 by 3. Yeah, do the simplification, get the answer probably. Yeah, it's 16 by pi, that's right. 2 power 4 is 1 by 2 power 4, that's right. This 2 coming outside, so 2. So what's the balance? The balance is 0 to infinity. Sine t by t whole power 4 into dt is equal to 2 by 3. So do the simplification, we'll get the answer. What is the answer? I don't know. Let us see. First of all, let us cancel the 2 first, right? So then what about the other one? The other one is 2 power 4. 2 power 4 come on. 2 power 4. 2, 2, 4, 4, 4, 16. I think 2 power 4, 16 we can cancel. So left hand side we have only 1 by pi is integral 0 to infinity sine t by t whole power 4 dt is equal to 1 by 3. Otherwise, just cross multiplying the 1 by pi to the next side, we'll get cross multiplying the 1 by pi to the next side, we get integral 0 to infinity sine t by t whole power 4 dt is equal to pi by 3. That's it. This is the answer. Right? Got it? So this is the way to get the extension, the detection of the given infinite integrals with the help of the complex Fourier transforms. Sometimes we apply the inversion formula, sometimes we may apply the partial identity, but how we will know which one is suitable for this? Let us check out the Fourier transform. The Fourier transform is power 2. See that? Sine square s by 2 by s square. Suppose the requirement is only power 2 here, then we apply the inversion formula. We'll get the answer directly. What is integral 0 to infinity sine square t by t dt? Answer is pi by 2. I made separate video for this one. Please kindly go and check it out. Sine t by t dt. Not only that, integral 0 to infinity sine t by t to the 4 square dt. These two answers are pi by 2. But power 4, so we can't able to generate this power 4 term from the existing available result. So better we can go for the power 2. So power 2 means use the Parseval's identity. But the answer is pi by 3. See that pi by 3 is the answer. I hope everyone you may like this lecture, this video. Please kindly share, subscribe and comment our YouTube channel ADC Max. Thank you so much.